This is Indira, Assistant Professor of Institute of Aeronautical Engineering from the Department of Mathematics. Today we are going to learn how to find out the particular integral in the second case, that is when q of x is equal to sin ax or cos ax. In the last two sections, we have seen how to find out the particular integral for e power ax, how to find out the complementary function. Okay. In the last section, we have seen how to find out the complementary function and how to find out the particular integral and how many types of functions that we are going to refer. I've said it before that we are going to refer 5 different terms of q of x, 5 different types of functions of q of x. In the first one, e power ax, already we have seen. Next, this is the second method when how to find out the particular integral when q of x is equal to sin ax or cos ax. Okay, so in this case, what we have to do, just we have to take the particular, what is the formula to find out the particular integral? Particular integral can be found out by f of d into f of a particular integral is equal to 1 by f of d into q of x. So this q of x may be e power ax or sine or cos, okay, sine or cos, or it may be x to the power of n. So based on the type of a function that we are taking, we have to choose the type of methods to solve the particular integral. Now, in this method, we have taken how to find out the particular integral when q of x is equal to sin ax or cos ax. This method is used for only these two types of trigonometrical functions. And if the trigonometrical function is secant or tan, this method cannot be used. So on a tan or cosecant or cot, this method cannot be used. This method is used to find out the particular integral for sine and cos only. So how to find out the particular integral in case of sine and cos? Okay, I'll take one example to show. Before that, let's see what are the formulas that we have to refer. Particular integral is equal to 1 by d into q of x. So which is equal to q of x is sin ax by 1 by d. 1 by d. In place of d, in place of d square, you substitute minus a square. In place of d square, you substitute minus a square. So this can be substituted such that f of a square is not equal to 0. Okay, f of minus a square should not be equal to 0. If f of minus a square is equal to 0, then the procedure cannot be followed. As in case of the previous one also, e power ax. What we have done, where we have substituted d is equal to a and we have seen whether it's equal to 0 or not. If it is not equal to 0, we have taken that as a particular integral. If it is equal to 0, then what we have done, we have multiplied the numerator with x and we have taken the derivative of the denominator and again we have tried to substitute d is equal to a. So in that procedure we have done to find out the particular integral for e power a. Now in this case, if the denominator is equal to 0 after substituting d square is equal to minus a square, then how to move further? Okay, there is a formula that is sin ax into f of d square plus a. You can see that if d square is equal to minus a square, the denominator value will become 0. So we should not do like that. So it can be written as minus 2 cos ax by phi of minus a square into 2a. You can write even the same formula for the cos ax also. Cos ax by f of d is equal to cos ax by d square plus a square into phi of d square, and which is equal to 1 by phi of minus a square into cos ax by d square plus a square. And this can be written as x sin ax by phi of minus a square into 2a. Now I'll take one example to give whatever we have discussed till now. Now take this example. Solve y double dash plus y dash plus y double dash plus 4y dash plus 4y is equal to 4 cos x plus 3 sin x. Okay, so this can be written as the y double dash. I've said that the y double dash, which will be equal to d square by dx square and which will be equal to d square. All the three representations are one and the same. So the question can be asked any form. Okay, so I have taken y double dash plus 4y dash plus 4y is equal to 4 cos x plus 3 sin x. Now, the extra thing that they have given some conditions also. These conditions are used to find constants. Find constants, that is C1 and C2, which are framed in the complementary function. Constants C1 and C2. Okay. So with the help of these two conditions, we are going to find out C1 and C2. Most of the questions he won't give these conditions. These are called as initial conditions. These initial conditions are used at the final after getting the general solution of the given differential equation. Okay. So afterwards we'll think of this constant. First, let's see how to find out the particular integral and complementary function for the given differential equation. Now you take the given differential equation in the operator form, that is d square plus 4d plus 4 into y is equal to 4 cos x plus 3 sin x. What is the auxiliary equation? Auxiliary equation can be brought by f of m is equal to 0, f of m is equal to 0, and f of m is nothing but, f of d. So this complete function is nothing but the f of d value. So you can write this as, so this complete function is f of d. So in place of d, you substitute d is equal to m to get the auxiliary equation. So auxiliary equation is m square plus 4m plus 4 is equal to 0. It is in the form of a plus b whole square. A plus b whole square can be written as a, that is a m plus 2 whole square is equal to 0. There are two roots, two real and repeated roots. Okay. Real and repeated roots. Okay. Now, how to find out? Give the complementary function c1 plus c2x e power minus 2x. Suppose if you have one more 2 here, minus 2, then c1 plus c2x plus c3x square e power minus 2x. These are all we have discussed in the previous sections. You can see it in the previous sections if you want if you have any doubts. That is the methods of finding out the complementary function. Okay. So yc is equal to c1 plus c2x e power minus 2x. So how this is a particular integral. Now put it as number 1. Now in the second stage, we are going to find out the particular integral. How to find out the particular integral? The particular integral is equal to f of d. What is the formula for particular integral? Particular integral is equal to 1 by f of d into q of x. 1 by f of d into q of x. Okay, so what is f of d here? 4 cos x plus 3 sin x divided by 4d plus 3 is a particular integral. Now we'll try to substitute these values. I don't have d square term here. Actually, what is the procedure? I should substitute d square is equal to minus a square. I should substitute d square is equal to minus a square. But d square term is not there here. Okay. I am considering only the one part here. It can be yp is equal to 4 cos x plus 3 sin x by 4d plus 3, which is equal to rationalizing the denominator, that is 4d minus 3 by 4d minus 3 into 4d plus 3. Okay. 4d plus 3, and how have I got this? I have got by substituting d square is equal to minus 1. If you substitute d square is equal to minus 1, what you are going to get here? Okay, let's see once again how you are going to get. If d square is equal to minus 1, you are going to get it as 1 by d square is equal to minus 1 plus 4d plus 4 into 4 cos x plus 3 sin x. And what is this value equal to? That is 4d minus 3. That's how 4d plus 3. That's how I got this value, 4d plus 3. Okay, so I got it. Now again, this operation has to be done until this d value is completely eliminated. Only one procedure I have, that is d square is equal to minus a square. I have to substitute this. But I don't have any. Here in the first stage I have d square. So happily I have substituted d square is equal to minus 1. But in the second stage, I don't have d square term. So you just rationalize this. Okay. So rationalizing the denominator. So rationalize the denominator. Rationalize the denominator. Rationalize the denominator to get d square term in the denominator value. So that we'll see in the next slide. Now, after rationalizing, what you're going to get? 4d minus 3 into 4 cos x plus 3 sin x divided by 16d square minus 1. Again, you try to substitute. D square is equal to, what is the coefficient here? Coefficient, that is the coefficient of x here, that you have to take, that is minus 1. Okay, so you try to substitute d square is equal to minus 1 and try to get the denominator value free from the differential operator d. So you're going to get it as minus 16 minus 9, which is minus 25. So this is completed. Now what about the numerator? Now multiply each and every term. D is nothing but the 4. You can write this as 4 into 4, that is 4 is taken outside. 4 d by dx, d by dx of cos x minus 3 cos x. Okay, this is the first term, minus 3 into 4 cos x, okay, plus 3 sin x. So what you're going to get? That is 4 into 4, 16. 16 minus 12, right? 16 minus 12. So 16 minus 12. So we are going to get, what is the derivative of cos x? That is nothing but sin x. Sin x. Derivative of cos x is sin x. Okay. So I'll repeat once again. 4 into d by dx of cos x plus 3 into d by dx of d by dx of here, once again, sorry, d by dx of sin x. Okay, d by dx of sin x minus 3 into d by dx of sin x. 4 into divided. So this is nothing but minus 16 sin x plus 12 cos x minus 12 cos x minus sin x. Okay, expand this completely. You try to expand this, then you are going to get this as a, which is equal to minus 25 sin x by minus 25 sin x. These two gets cancelled, leaving sin x as a answer. So the particular integral is very simple, that is sin x. This is the particular integral. So this is how we are going to find out the particular integral for the sin x and cos x. Now again, what is our general solution? The general solution is nothing but complementary function plus particular integral. Complementary function plus particular integral. So the complementary function which we got in this case is c1 plus c2x e power minus 2x plus sine 2x. So by the now the problem is not yet completed. We have there is a boundary conditions which are given in the question. That is, we have boundary conditions given in the question. What are the boundary conditions? Y of 0 is equal to 0, and we'll move that is y dash of 0 is equal to 0. Okay, y of 0 is equal to 0, y dash of 0 is equal to 0. Now you take this one. Okay, so what we have got it, y of x is equal to c1 plus c2x e power minus 2x plus sin x is a complete answer. We got it. Okay, so put x is equal to 0. So y of 0. So y of 0 is equal to c1 plus 0 into e power 0 plus sin 0. Sin 0 is 0. So what is which is nothing but, and here, and this value is given as 0 because he has given in the question. So that implies c1 is equal to 0. That is how we are going to get the value c1 is equal to 0 in this case. Okay. Now next, differentiate that with respect to x. once again. Okay, differentiating with respect to x. So what you're going to get, the u into v rule. Okay, d by dx of u into v rule. Okay, u into v, that is nothing but u v dash plus vu dash, vu dash. Now uv dash, this is nothing but u value, derivative of the e, that is nothing but e power minus 2x, internal differentiation, that is minus 2. So minus 2 into e power minus 2x plus e power minus 2x is as it is, and derivative of this term u, and here I'll get the first term, I don't have any x value, that becomes 0. The second term I got x value, that is c2, and it runs like a coefficient here. So plus cos x, plus cos x. Now given y dash is equal to 0, y dash, I got this y dash, put x is equal to 0 in y dash, put x is equal to 0, put x is equal to 0. So what you're going to get, that is 2 minus 2 c1 plus c2 plus 1 is equal to 0. And c1 is already 0. C1 is already 0 in the previous case. What we got it. So here I got c2 value, that is minus 1. So you substitute that in the required solution, y is equal to c1 plus c2 in the previous this thing, that is what is the general solution, y is equal to c1 plus c2x into e power x, e power minus 2x, okay, plus sin x. So you just substitute c1 is equal to 0 here and c2 is equal to minus 1. So you're going to get the solution as a minus x e power minus 2x plus sin x is a complete solution after substituting the initial conditions. This is how the problem can be done for the non-homogeneous equations with the q of x is equal to sin ax or cos x. Now let's go with the next example. Solve d square plus 9 into y is equal to cos 3x. Given the equation is d square plus 9 into y is equal to cos 3x. The auxiliary equation is m square plus 9 is equal to 0. How will get the auxiliary equation? F of m is equal to 0. The auxiliary equation is f of m is equal to 0. That is just you have to substitute d is equal to m. So I got the two values, that is a complex value, complex roots. I got the complex roots here, plus or minus 3i, complex roots. Now it can be written as the complementary function is, actually we'll have this into e power 0x as I don't have the real part here. I don't have the real part here. So it can be written as c1 cos 3x plus c2 sin 3x e power 0x. And it can be written as cos 3x by d square plus 9, and which is nothing but cos 3x by d square plus that is 3 square. Okay, 9 can be written as 3 square. Okay. Now, if I substitute here, if I put, actual the procedure is d square is equal to minus a square is a procedure, and a is nothing but 3 here. Okay, here a is nothing but 3. So I can't substitute here. Okay, so d square plus 9 means what I'm going to get, we are going to get minus 9 plus 9, and which becomes 0 here. So I should not take this direct substitution of this d square is equal to minus a square. Instead, I can use this formula, that is x by 2a into sin 3x, okay, which is equal to x by 2a. A is nothing but 3 here. So x by 2 into a into sin 3x. This is the formula. So x sin 3x by 6 is a that is a particular integral for whatever question that we have taken, that is cos 3x. Again, you add with the complementary function to get the general solution. C1 cos 3x plus C2, C1 cos 3x plus C2 cos 3x plus x by 2 sin 3x is the solution for, here we got, this should be sin 3x, okay, plus x by 2 sin 3x is a solution for the given differential equation. Now let's move to the next example. Solve d square minus 4 into y is equal to cos square x. I'll repeat. Solve differential equation d square minus 4 into y is equal to cos square x. Now, this cos square x can be changed. 1 plus cos 2 theta by 2, so that we can get cos 2x, because we have the procedure for only cos ax and sin ax. We don't have any specific procedure for sin square or cos square. So that have to be converted in terms of cos 2 theta, 1 plus cos 2 theta by 2 or 1 minus cos 2 theta by 2. So first we'll think about how to find out the auxiliary equation. As usually, the auxiliary equation is d square plus minus 4 is equal to 0. D minus 2 into d plus 2 is equal to 0. D is equal to plus r minus 2. So the roots are 2 and minus 2, which are real and distinct. Okay, real and distinct. The complementary function is c1 e power 2x plus c2 e power minus 2x. Now, how to find out the particular integral? What is the formula for particular integral? Particular integral is 1 by f of d into x, 1 by f of d into x, and which is equal to 1 by d square minus 4 into cos square x. Cos square, we have a formula, 1 plus cos 2x by 2. So, 1 by d square minus 4 into 1 plus cos 2x by 2. This can be written as 1 by 2, you take it outside. So 1 by 2, 1 by d square minus 4 into 1 plus cos 2x. Now this can be written as this can be written as e power 0x. So e power 0x plus cos 2x into 1 by d square minus 4. So 1 by 2, 1 by d square minus 4 e power 0x plus split that into two different parts. Okay, multiply this total terms with e power 0x and cos 2x separately. So 1 by 2, 1 by d square minus 4 into cos 2x. Now here what I have to do, I have to substitute in the first case. In the first case, you can write it as yp. Yp is equal to yp1 plus yp2. If you couldn't able to do both the parts directly, you can write like this. So yp1 is equal to 1 by 2 e power 0x by d square minus 4. Okay, now what I have to do, I have to put d is equal to 0. So what I am going to get, that is by e power 0x by minus 8. This is a yp1 value. Now next is yp2 value. Yp2 value 1 by 2. Okay, 1 by 2 cos 2x by d square minus 4. So what is the procedure? Put d square is equal to minus 2 square. So what are you going to get? 1 by 2 cos 2x by, that is minus 2 square minus 4. So which is nothing but minus 1 by 16. Minus 1 by 16 cos 2x. So hence the general solution of E is given by y is equal to, that is y of x is equal to complementary function plus particular integral. Complementary function is c1 e power 2x plus c2 e power minus 2x plus 1 by 8. This is a value which we got it for yp1 value, and plus 1 by minus 16 which we got for yp2 value. So cos 2x.
Like, share and subscribe. Hit the bell icon for more updates.